Hello, pre-calculus students. Today we're going to be going over solving quadratic trig equations and the solutions to this. We have an assortment of problems, and I have two that actually we worked on already in class, if you were in class with us. And these were just solving a basic quadratic with a constant term. Here's a quadratic, here's a constant term. And the other one was solving one which needed to be factored as a trinomial and then solved. So the purpose of this video is to go over solution techniques for the remaining problems. And I just want to point out to you on the side over here on the right, I have the trig reference triangles that you see on the SAT, and I have the the four quadrants, which have ASTC, which stands for the quadrants in which those designated trig ratios are positive. And then I have the quadrantal chart that we went over in class. So we're going to use those from time to time throughout the course of this video. But the purpose of this video is to go quickly through the solution techniques for the remaining problems. So on number 3, what we have is another quadratic and a constant term. So we solve for cosine squared of x, and we just add the 3 over to the other side and divide by 4. We have the cosine of x is equal to plus or minus root 3 over 4, which turns out to just being plus or minus root 3 over 2. We break that up into two separate equations. We have cosine of x is equal to root 3 over 2 in the positive sense, and cosine of x is equal to root 3 over 2, but with a negative. So now we get into what is the reference angle. Well, we look over at the 30, 60, 90 triangle, and we see that our cosine ratio is root 3 over 2. So if it's root 3 and 2, then we have the reference angle for cosine would be 30 degrees. And then that means we have a 30-degree angle in a positive quadrant for cosine. So that would be in the first and fourth quadrant. So I'm going to write Q1 here and Q4 here. And in the quadrant 1 angle, the reference angle is 30 degrees. Then the angle is 30 degrees. But in quadrant 4, if the reference angle is 30 degrees, I'll draw the 30-degree angle, reference angle, and the angle in standard position is actually 330 degrees. Moving on to the next problem, the reference angle for this one is still the same as before. It's because the ratio of sides was root 3 over 2. And our solutions for this one, because it's negative, we're going to be in quadrant 2 and quadrant 3. So when we go to quadrant 2 and quadrant 3, we are in, we have a 30 degree in quadrant 2, and that would be a 150 degree angle in center position. And then when we go to quadrant, wait, did I say quadrant 3? I'm at quadrant 2. If I said quadrant 3, I apologize. In quadrant 3, we have a 210 degree angle. That's how we solve that one. Moving right along, we need to factor this trinomial. It's if you use the x method of factoring, you would ask what multiplies to give you 2. That's the AC method. Adds to negative 3, and that would be negative 2 and negative 1. We rewrite that as 2 cosine squared of x minus 2 cosine of x minus cosine of x minus plus 1. We do our grouping. So you have 2 cosine squared of x minus 2 cosine of x, and then I'm going to do plus negative cosine of x plus 1. I'm going to take out what's common to both. In the first one, I have 2 cosine of x coming out, and that will be cosine of x minus 1. In the other one, I'm going to factor out a negative 1. And I'm going to have just cosine of x minus 1 for the second term. Remember, this is all equal to 0. So now my factors are going to be 2 cosine of x minus 1 times cosine of x minus 1, again, equals 0. This breaks us off into two separate paths. We have 2 cosine of x minus 1 equals 0, and cosine of x minus 1 equals 0. We solve for cosine of x, we get 1/2. For this one, cosine of x equals 1. So now that we know these little bits of information, for the left side, we know our reference angle is going to be, if the cosine ratio is 1/2, we know we're dealing with adjacent hypotenuse. The angle now is 60 degrees for the reference angle. The first angle it's a positive angle, so it's quadrant 1 for cosine and quadrant 4 for cosine. And doing what we did before, the first angle is going to be 60 degrees in quadrant 1. And the second angle is going to be 300 degrees in quadrant 2. However, when we do the next problem, we say, when is a cosine equal to 1? This doesn't fall under the reference triangles, because this is basically a quadrantal value. When is a cosine equal to 1? And that happens looking at our chart. We see at 0 degrees and at 360 degrees. So our answer for this is going to be at 0 degrees. Now, the reason why I'm not choosing 360 is because in the beginning of our problems, we limited our domain for our answers to be from 0, including 0, up to but not including 360. So keep that in mind as you submit your answers. So on the next set of problems, we have some more factoring to do. But instead of boring you to death with the factoring, I'm going to pause the video. I'm going to put the factors up as if we factor them, from scratch, because this is really something that you should be able to manage at this point. And then we're going to solve the actual trig equations. If you have a question with the factoring, you should ask me in class, or perhaps comment on the video, and I'll put up another video to show us how to factor these trinomials. Okay, so I have all the factored forms of the trinomials. I checked them, and so in getting started, once you get factored, you then break the two solutions up into two separate parts, and you're trying to solve, for instance, on this one, you have 2 sine of x plus 1 equals 0, and sine of x plus 1 equals 0, and you have two solutions. The solution on the left is going to be sine of x equals negative 1/2. The reference angle will be 30, because the first answer is in quadrant 3. The first solution will be 210 degrees, and the reason why quadrant 3, sine is negative in quadrant 3, and it's negative in quadrant 4. So the next solution would be a 30-degree in quadrant 4, which is 330 degrees. On the right side, the sine of x is equal to negative 1. Looking at my chart, I know that when I'm at 270 degrees, the sine of x is negative 1, so my other answer would be 270 degrees. Looking to this next question, number 6, I have one solution. When is sine of x equal to 2? Never. So on this side, no solution. I explained in class what the range of the sine function is. The sine function only ranges from negative 1 to 1. So as a result, there's no solution for that. But for the second part, sine of x plus 1 equals 0. So the sine of x equals negative 1. And when you look on the chart, again, the angle is 270 degrees for that. Moving down to the next ones, number 7. After fully factoring that, we have, again, another problem to solve. When is 2 sine of x plus 1 equal to 0? Just as we did before. That's looking for the sine of x is equal to negative 1/2, and we just did this one. I feel like I've just done the same exact problem, but it is in fact different. But the reference angle is 30 again. The first solution is 210, and the second solution is 330 in quadrant 4. But we have on the other side, we have when is the sine of x minus 3 equals 0. And when we solve for sine of x equaling 3, the answer to that is never, because the range of the sine function, okay, never reaches, it's all, the range is from -1 to 1, everything included, but nothing outside of that range. On this next problem, we're looking for where the cosine of x is equal to 1/2. The reference angle, as it was up above, is 60 degrees. Since it's positive, our first and our second answers are in quadrant 1 and quadrant 4. So 60 in quadrant 1 is 60 degrees, and 60 in quadrant 4 is 300 degrees. The other one has no solution because cosine of x is never equal to -2. It's not in the range of cosine of x. The last two problems, we have the secant of x. We factor out, we have two terms, so we factor out the greatest common factor. Secant of x is equal to 0. That means that the cosine of x is equal to 1 over 0 by reciprocal relationship, and that means cosine of x is undefined in value. And that has no, the answer for the angle that makes cosine undefined is, does not exist. So for this, there is no solution. Let me just spell that right. No solution. And for the other part, the secant of x equaling equaling -2 equals 0 means the secant of x is equal to 2. That means the cosine of x is 1/2. That has two solutions. The reference angle is 60, just as it was up above. And we have two solutions from quadrant 1 and quadrant 4. That's where cosine is positive, and that would be 60 degrees and 300 degrees. Last problem, as we reach the 12-minute mark, we had factored the greatest common factor out to get the cosine out. Then we had to factor that trinomial. We have all three parts, so we have when is the cosine of x equal to 0, when is 2 cosine of x minus 1 equal to 0, and when is the cosine of x plus 1 equal to 0. Cosine of x, I'll start on the right, is equal to -1. From our chart, that angle is 180 degrees. On the one in the middle, cosine of x is equal to 1/2. Again, we've done this several times tonight, but these problems work out a lot of times, have the same ratio we're looking for. The reference angle is 60 degrees. The first and second solution are in quadrant 1 and quadrant 4 because the ratio is positive. And the first answer for this is going to be 60 degrees, and the second one is going to be 300 degrees. Last one, when is the cosine of x equal to 0? Looking at our chart, it's at 0 degrees. I hope this video has helped you understand the process in which we go to solve these quadratic or nonlinear trig equations. And please comment on the video on any portion of it if you'd like to see something else explained. Thank you and have a good night.